Hi, we're going to take a look at this problem. This is a fairly standard calculus problem when you have to determine values to make a particular function continuous. So what do we have here? We have a piecewise function, and if you forget about the conditions here, each one of these functions, 2 minus x squared, ax minus b, which would be a linear function, and 1/2 x minus 5, each one of them is continuous individually. But the problem is when we connect it together, what's going to happen? How they're going to connect together? So what we are going to do is we're going to use this. So what we want is we want for this to be continuous here when you join these two functions. And that would require that when you approach one from the left and you approach one from the right, these two functions will be the same. So if I set the limit as x approaches 1 from the left of f of x, that would be 2 minus 1 squared, which will be 1. So then when I do the limit as x approaches 1 from the right of f of x, now I plug in 1 into this function, which will give me a minus b. And I clearly want for them to equal each other because that's the requirement for continuity, that first of all the limit must exist. So we can conclude from there that a minus b must equal 1. Alright. And the same exact situation has to happen with these two functions. So at 6, when you approach 6 from the left and when you approach 6 from the right, you want to get the same exact value. So the limit as x approaches 6 from the left of f of x will be, we substitute 6 in here, so it's going to be 6a minus b. And when you plug in the limit as x approaches 6 from the right of f of x, you're going to substitute into this function, and that's going to give you 1/2 times 6, it's 3, 3 minus 2 is negative 2. So here we're going to have 6a minus b equals negative 2, and we want these two equations to be solved together. When you solve them together, you will get your values of a and b that will make this function continuous. The easiest way probably to do it is by elimination. So if I subtract them, I'm going to get negative 5a, b is going to cancel, equals 1 minus negative 2, which will give me 3. A is going to equal negative 3/5. And I take this value, substitute it into either one of these two equations. So let's say if I go into the first one, that's going to be negative 3/5 minus b equals 1. So negative b equals 1 minus plus 3/5. So negative b equals, that would give us 8/5. And b will be negative 8/5. And these are the two values that we need. This will make this function continuous. Again, the main idea behind this is that you want for one-sided limits on either end, in this case for 1, and over here for 6, to be equal. This will establish continuity at each point individually, but the only way we can do it here is by setting up a system of two equations because we have two unknowns. Okay, hope this helps.